Good afternoon, everyone. Today's video is going to be about a pretty famous problem called the Monty Hall problem, which involves a person and a game show host. And what this person in the game show must do is they must open a door to reveal a car. So the way this goes is the person, right, well, three doors are closed, obviously, and you choose one door at random. And then what happens is the game show host, what he does is opens the other door with a goat. So for example, if you were to choose door number 1, the host would open door number 3 and ask you to choose between doors 1 and 2. If you were to choose door number 2 first, the game show host would either open door number 1 and 3 and then ask you to choose between door number 2 and the remaining door. Right, so it's this simple. However, it does seem to be confusing a certain amount of people, I've noticed, and which is why I'm going to try my best to explain it in this video today. So, right, let's look at it more concretely. Right, so at first, there's one door with the car behind and 2 doors with goats, which means that any choice you make will have a 1%, a 1/3 chance of being correct. So let's assume you choose door number 1. So then the host opens door number 3 to show you a goat, and then asks you whether you would like to stick with your choice, so door number 1, or would you like to switch doors and go for door number 2. Now, a lot of people, understandably so, think that at this stage it doesn't really matter which door you pick because they are both 50-50 chance of having the car, which would be correct if you had just been an onlooker, just arriving upon the scene and just being asked to choose, right, you got a car behind either door number 1 or 2 and then pick one. In this case, it would actually be 50-50 chance. However, having opened the previous door and knowing which door was picked first is actually a pretty important piece of information, because that allows you to make a more informed choice, and we shall see why right here. So let's consider a person that always sticks with their choice, right? No matter what, he's going to stick. So he picks a door. This door has got a probability of 1/3 of being the door with a car behind, so it's got a door, so he's winning the car, and he sticks with this door. So luckily, he wins and gets the car. However, he's got more chance of picking the wrong door at first, of course. I mean, it's got 2/3 chance of picking a goat, and then if he sticks with his choice, he loses. So this does not look like 50-50 chance. And let's look at the scenario of a person who always switches. So in this case, he picks door 1, still got a 1/3 chance of being correct, yeah, and then switches and then loses, unfortunately. However, let's look at this. He's got more chances of picking a goat on the first choice in the car, obviously, and therefore by switching he ensures he is going to win, obviously. So this is not actually 2 choices. It's not a choice with 1/3 probability and then a choice with 50-50 probability. It's actually the same choice, that and the consequence of you winning or losing actually follows directly from your first choice, which therefore means that actually it's always better to switch, because this is always going to guarantee you an extra 1/3 probability. Now, this might be a bit confusing to understand, so what we can imagine is a scenario. Instead of having 3 doors, we can imagine we have 1,000 doors. I mean, I think there's more like 700. Yeah, it's got to be 700 doors here. Right, anyway, behind one of which is a car. So it could be this one, it could be this one, it could be this one, it could be this first one. And all the others have goats. And the principle is still exactly the same. You pick a door at random, and then the game show host opens all 998 doors. So let's assume that there's 1,000 doors. The game show host opens 998 doors with goats and leaves you with 2 doors, your original pick and another door. And what happens is the probabilities still work the same. You have 1 out of 1,000 chances of picking the car on the first draw, correct? And then you have 999 chances out of 1,000 of picking the incorrect door. Now, if you stick, you have 1 in 1,000 chance to properly win the car. And if you, it's pretty much this scenario at the extreme. Whereas if you switch, you have 1 out of 1,000 chance of losing, which is the probability that you pick the correct door at first, which is pretty small. And the way to think about it is, honestly, it's a more informed choice. It's not 50-50 because you have more information. Because what happens is, it's as if you were going to go on a plane, for example, and you know one of those planes is going to crash, and then so you're hesitating, and then what happens is the engineers come over to you and say, like, right, this plane is probably going to crash and this one is probably not going to crash. Which plane are you going to take? Right, well, it's probably not to better not to get on the plane at all, but you understand what I mean. Like, you want the one who's probably not going to crash. And obviously this a person not knowing this information from the engineers would just have a 50-50 chance of crashing or not. However, you, having had the information, the extra information, you can make a more informed decision and therefore have a higher chance of winning the game than losing. Right, so I hope I've explained this clearly enough. If not, then feel free to drop me some questions, and I shall do my best to answer them. But just know that the maths does check out. I could do a video with in Python, and just to prove it. And yeah, so any questions, let me know, and thank you for listening.